we'll have to make sure that the X takes into account possible tiling. So we set, just like we did before, the X and Y to be tileable. And then we can grab the color using the get pixels function from the map that we know that it's a bitmap, so we can read pixels from it. We get the UV coordinates X multiplied by the map width and the map height minus the UV coordinates Y multiplied by the map's height. And what we have to get is just a single pixel, and from that pixel the result is from get pixels is always an array, so we get the first element of the array, which should be the pixel. At this point we are done and we can return the color. What happens here is, if there was no bitmap, the result is going to be the diffuse color being returned, and if there was a bitmap, the result is going to be the color that we got from the bitmap. In an advanced version, we could also take into account the map amount spinner and multiply the one color with the other in order to get the tinting of like 50% of the diffuse channel and 50% from the texture. But at this point, we're going to take either 100% texture or 100% the diffuse color if there is no texture. Having this function, we can call the function from inside the body of the fire array function. In addition to getting the object by index, we're going to also get the material definition with the same index using the materials array, and the same index as the object. Having this, we can initialize the diffuse lighting slightly differently this time. We'll take the diffuse lighting, we'll move it after the z-depth calculation, and we'll set the material definition element number 1, which is the ambient component. We'll multiply it by the ambient color, which is a global variable, returning the ambient color specified in the environment. This is this color here. We can set this color to green, and the objects in the scene are going to react. We can also set it to orange, and this is going to brighten up the shadow areas. If we take a look at the color again, we have a new RG values. The B is still 0. This is going to be our diffuse lighting, the initial color, before we start calculating the diffuse component. Now, the last surface color is not going to grab directly the wireframe color from the object, but we're going to call the function that we just created, the getDiffuseColor function. We'll pass the index of the object to get the correct material, and the intersection that we calculated using the intersect ray, and then multiply the result by the diffuse lighting that we calculated using the dot product of the rays previously. At this point, we should have ambient light implemented in our rendering, and support for standard materials, and also the previously used wireframe colors should still work because of the default case. Let's assign a new material to, let's say, the teapot. This is a diffuse map which is currently respecting the ambient color, and we can try to evaluate our script to see what rendering we're going to get. And as you would expect, the ambient color is being taken into account, and also the diffuse color from the standard material was also used instead of the wireframe color. Now we could try to add a texture to the diffuse channel. For example, we can try a checker map in an explicit map channel number 1. If we would show it in the viewport, we get this look, and if we would evaluate, we should get the texture on the teapot. So this procedural texture was converted into a bitmap using the render map function, and then we looked at the barycentric coordinates and picked the corresponding pixels from that 2D representation of the procedural map. Of course, we could use a normal bitmap texture and project any image that we want, like we did before. So at this point we have the ambient component and we have the diffuse component. The only thing that is left is the specular highlight, which is the most complex calculation in the typical font shading. We're going to implement blend type of specular highlight in the next step of the development.